Another geometric figure that's helpful to understand is one about an angle. An angle is where I have two rays that intersect at a vertex, and the distance between two of those rays can open or close. How we describe this particular angle right here, we can describe this angle in several ways. One way we describe this angle is we can describe it as angle B, because B is at the vertex. We can also describe it as angle 1, because 1 is the identifier that I put inside at the vertex. I also describe it by the dots or the points along the way. So this could also be described as angle CBA. And I can also likewise describe it as angle ABC. Angles are divided up into degrees. And if this ray were to go all the way around and connect back to the other side, it would have made one complete rotation. And that complete rotation or revolution is 360 degrees. So each degree can be divided up into each spot can be divided up into 360 areas, each one being 1 degree. So 1 degree is 1/360th of a way around a circle. With angles, we can also understand triangles. And the key point to understand with triangles, and I'm going to say this one, I'm going to put a little mark there that tells me I have an angle. I'll put another mark. I have 2 on that one, and I'm going to put 3 on this one. Don't always have to be 1, 2, and 3, but this means that this angle is equal to any other angle that has the same mark with 1 in it. So this one has 3 angles, which all triangles do, but none of the angles are the same or congruent. I could contrast that with maybe an angle like this, where the base angles are the same, and maybe the top angle is different. We can make triangles within triangles many different ways, but these marks tell us that they're equal to another angle inside. Now, we talked about going all the way around is 360 degrees. Another key geometric understanding is that the angles inside of a triangle, they all add up to 180 degrees. Regardless which triangle you have, the interior angles of a triangle sums up to 180 degrees. So an example that we can explore by understanding that the interior or the sum of the interior angles of a triangle equal to 180 is this word problem that just looks yuck right now. What it says is that the first angle, whatever angle that is twice the measure of the second angle. I also have a third angle, which is 20 degrees less than that of a second angle. How in the world do I make sense of that? Well, as I mentioned before, maybe a good thing to do is just start with a picture. Then from there, let's describe one of the angles that we know absolutely nothing about. Well, we know the first angle is twice something. The third angle is less than something. What's that something? It's that second angle. So I'm going to let the second angle equal my x. I don't care which angle it is, but I'm going to write it in terms of x. So this is my second angle over here. My first angle then, can I write that in terms of x? I don't want to create multiple variables. I don't want to make it x plus y plus a z. That doesn't help us. They have to be all in terms of the same variable. So the first one is twice that of the second. Well, the second is x. The first one is just twice that. And then the third angle is 20 degrees less than the second. So x minus 20, because it's 20 degrees less than the second. So I was able to describe each of my unknowns in terms of a variable. I remember that the sum of the interior angles equals 180. So what are we going to do from here? Well, let's add them up. So 2x plus x minus 20 plus x equals 180. Now notice I was able to create an equation with one unknown. That's a good thing. It means I could solve it. Add up my like terms. 2x plus x is a 4x minus a 20 equals 180. Add 20 to both sides equals 200. and divide both sides by 4, leaves with a 50. There I go. Solved the equation. Yeah, but I didn't solve the problem. So what are the measures of the angles? Well, x equals 50, so the measure of my second angle, this is 50 degrees. The measure over here was twice that, so this one's 100 degrees. And the third one is x minus 20, 50 minus 20, which is 30 degrees. And then I have to make sure that 100 plus 50 plus 30 all add up to 180. There's my check. They do, so those are the measures of each particular angle within this triangle that satisfies that original or those original conditions.